Hey students, we are moving on. This is lesson 3.3 properties, and I forgot to write in where it says 3.3. So we're talking about 3.3 and we're talking about the properties. Now those properties are associative, commutative, then we have distributive, which we're going to get into in a lesson later on, but I will introduce the concept of distributive today. And then we are also talking about identity. And there is addition and multiplication for each of these. So add and then multiply, I'll use the dot to show that. So you can add, you can have associative addition and multiplication, commutative property, addition and multiplication. Distributive is its own little thing, and identity you can have addition and multiplication also. So we're going to go through this. I'm going to be upfront and honest with you. This is one of those lessons where you need to listen to the entire video, and you need to participate in every one of the activities. Properties are like the rules. They're like, for example, when you're writing, they're in language arts, there are certain rules that you have to live by, and you do have to do that in this also. All right, guys, let's start out this lesson with doing our bell work. So the first question we're going to look at is write an expression to represent 22 less than x. Now, if you remember a lesson or two ago, we talked about that when we see this word then, it means we flip-flop the numbers or variables, whatever's being discussed. And we know less means subtract. So we're going to take the 22 over here and the x over here. Now, if you look at that, that says 22 less than x. Because if we have x and we take 22 less than that, that's what it looks like, x minus 22. All right, let's move on to number 2. A piece of wood was cut, so the length was 3 3/10 inches, and the width was 1 2/10 inches. What is the area of the wood? So we are going to, let's get us a piece of wood to kind of examine here. So there we go, there's our piece of wood. The length is 3 3/10, and the width is 1 2/10, and it wants the area. Now, again, if you remember our formula, if we have the length times the width, or in our case, I'm going to start referring to the length as the base times the width, it gives us the area. So we have the base, we have the width, we are going to multiply them together, and let's do it. Let's get out a good color here. So 6, 6, put a 0, 3, 3, we get 6, 9, 3, move the decimal over, 1, 2, 1, 2. So we have 3 96/100 inches squared. That is the area. That is all of this inside that piece of wood. So hopefully that makes sense to you and what we did there. Let's take a look at this. This was from a lesson or two ago also. So our terms in this expression are 3x, y, and 4. Notice I left the square off there because that squared is an exponent. It is what's happening to the variable, but it's a different process. It's a different function. So 3x, the y, oh, well, I am going to put the squared on that. So 3x squared, the y, and the 4. The coefficients would be 3x, and that's it. Oh, and the y, sorry. Remember, when there is a y, there is really a 1, so it is a coefficient. So we put that. Then we have x, we have y, and the constant is 4. So there's your bell work. Pretty simple, pretty basic. Hopefully that made sense to you as we did it. Let's move on. All right, so we are now looking at the notes. This is page 52, so you need to get out your journal, and you need to turn to page 52. So let's go through some of these properties so you can kind of see them. So if I am looking at these properties of operations, you can see in your journal that we have this associative property of addition, and you can see that we went from A plus B in parentheses plus C, and that it looks, the parentheses changed. So associative, what it makes me think about is association, grouping. You can group things in different ways. So the way that we associate things is the way we group things in different ways. So that's what it makes me think of. Commutative property. If you commute, it means you move. So some people have to commute to work. That means that they have to travel. It means they move somewhere. And so as you can see right here, what the difference in between the equal signs is that A plus B is B plus A. So they moved. The numbers actually moved. The additive identity property of 0, it means anything plus 0 equals itself. The existence of additive inverses. So for every A, there exists a negative A, so that A plus negative A equals negative A plus A, which is 0. So what it's basically saying is that, that's way complex, is that for every positive, there's a negative, and when we add those together, we get 0. We have the associative property of multiplication. Well, remember, we had the associative property of addition up here. We have it for multiplication too, and it's the same thing except it involves multiplication. So that association, that grouping takes place, and you can group things in different ways, but it doesn't change the value. It just changes the grouping. The commutative property of multiplication means that A times B equals B times A. So again, commutative means move, so it moves, but it doesn't change the value. The multiplicative identity property of 1, I know that seems like a big word, multiplicative, but it means multiplying identity property of 1. So it means anything times 1 is itself. So it's a complex way of saying something very simple. And then the existence of multiplicative inverses. For every A that is not 0, there exists an A that is 1 divided by A, so that, you know what, we're going to skip that one for right now, because I know that we talk about it when we talked about reciprocal, and we talk about it when we're dividing fractions. That's what that one is. And then we have the distributive property of multiplication, and we're going to talk about that one in the next couple of days, not in this lesson, but I will talk about it a little bit down here, because you are aware of it, because we have actually talked about it a little bit. So again, the associative property, the grouping, you can see that these groupings have changed, but the value didn't. So you can see 2 times, well, we would do this first, because of order of operation. 3 times 4 times 2 is 24, and 2 times 3, which is 6, times 4 is 24. So the grouping of factors doesn't change their product. The commutative property, the big idea on this one is the order of factors doesn't change their product. So A times B equals B times A. So there's your example with the 2 and the 4 and the 8. The distributive property, this is actually, I like to think about the Walmart distribution center, because we have that big building as you go north out of St. George, and it is a distribution center for Walmart. They have all their products that they sell in Walmart that go to that warehouse, and that warehouse takes part of those parts and ships them to all the Walmart stores out there. And this is kind of like, right here, this is kind of like the Walmart distribution center. And these are like the stores that are at all over the United States. And so what happens is this Walmart distribution center sends part of it here and part of it here. And we do call this Santa hat sometimes, because you can see it made kind of a Santa hat there. So this number times this number, and this number times this number. So it distributes itself to what's inside the parentheses. And we will talk about that in the next couple of days also. So let's take a look at these notes here. So it wants us to use the commutative property with this expression. And remember, commute just means move. So we're going to write an equivalent expression, which is x plus 5. Okay, on this next one, it wants us to distribute. So again, 7 times x plus 21, because 7 times 3 is 21. We distributed. Associative, it means that we're moving the grouping, and the grouping is parentheses. So we're going to go A plus B plus C, but we're going to put the grouping around the B and the C instead. This next one, distributive again, 4 times 2y is 8y. 4 times negative 5 is negative 20, so that's pretty basic. Associative on this one, well, how can we regroup this? We can go 7 times 3 times x. So we change that grouping, but it doesn't change the value. It's still going to be 21x. And then commutative again, 7 times c times 7. Okay, so let's take a look at this, what it wants. It gives us the first expression and the second expression. Well, what happened? Well, the grouping changed. So if the grouping changed, it's associative. On this other one, we can see that that's distributive because that number is being distributed into the other numbers in the parentheses. I'm going to abbreviate that. This one, the grouping changed. So if the grouping changed, the way that those numbers associate has changed. This one, it looks like the numbers just changed places, so that's commutative. On this next one, another distributive. And this one, it looks commutative because the numbers just changed. There we go. Okay, so now let's talk about the identity property of multiplication. Well, let's use we'll do a couple here. So what it's saying is A times 1 equals A. So we'll give another example. So let's say we have 7 times 1 equals A. Okay, so anything times a 1 equals, oh, not A, I'm sorry. I made a mistake. There we go, 7. The identity property of addition is A plus 0 equals A, or 7 plus 0 equals 7. So anything plus 0 equals itself. So hopefully those notes kind of can help you to be successful on your assignment here in just a minute. All right, so let's go through the practice really quick. This is really nice because it gives you kind of an example. It shows you what the commutative property looks like. So we went, oh, 5 plus 3 equals, or 3 plus 5 equals 5 plus 3. This one is saying 7 times 8 equals, well, 8 times 7. On the next one, A plus B equals B plus A. So pretty easy. Commutative just means switch them. Associative property, so this is giving us a good example of that. 7 plus 3 in parentheses plus 5 changed to 7, or 7 plus 3 with the parentheses just moved to the 3 plus 5. So we're going to do the same thing here. We're going to go, and I'm going to zoom in a little bit closer so we can be a little bit more exact. I'm going to change just write the numbers down. 7 times 2 times 4, and we want to change the parentheses to right there. On the addition, same thing. We're just going to go A plus B plus C. And since the parentheses were around the B and the C, we're going to change it to the A and the B. So basic stuff, just changing the grouping on that associative. Addition property of 0, okay, well, our example is 9 plus 0 equals 9. So what is K plus 0? Well, it equals K. 7 plus what equals 7? 0. So really simple on that one. The next one, we are looking at 3 times 0 equals 0. So what does M times 0 equal? 0. T times what equals 0? 0. And then the property of 1 is 1. 4 times 1 equals 4. So what does B times 1 equal? B. And then 6 times 1 equals 6. So those are the properties, and you might be wondering, why are we going through these properties? Well, we're setting you up to use things in algebra. And that is what this is all about. It's trying to get you to use these properties because these are going to be used to be able to do things in algebra. Again, which property the statement illustrates. Well, what happened here? Well, the numbers switch spots, so we know it's commutative. So I'm going to abbreviate to save some time. Well, what happened here? Well, we have identity of 0 happening. What happened here? Well, the numbers switch spots, so it's commutative again. What happened here? Well, the parentheses changed places, so it's associative. This one, it's 17 times 1, so we know that it's identity of 1. And then this one, the parentheses changed again, so we have associative. So not too difficult since we've kind of been doing the same thing over and over here. Now it wants us to simplify this expression. Okay, so if we want to simplify the expression, it's 8 plus 7 plus x. Well, those properties, those numbers are like terms from what we did the other day. So 8 and 7, they can go together. So we have 15 plus x. We can't combine that x with that 15 because it's not multiplication. So the like terms, the x is different than that constant. So we can't combine those. Now on number 18, it's a little bit different. We can go 10 times 11a. So we have 110a. And that's the answer. So not too difficult on that practice. So hopefully that helps you to be able to do your assignment. So let's take a look at that assignment now. All right, as I'm looking at this assignment, I can see that it's pretty much the same stuff that we've been doing. So if you did the practice in the video, you did your notes, you should be able to do this very easily. Also, if you would like to refer to your notes, you're more than welcome to do that. Oh, by the way, anybody from Mr. Roberts' class, if you would please take your assignment page, and I want you to write this down at the bottom. I want you to draw this down at the bottom. Draw that down on the bottom right-hand corner of your assignment. Thank you. Until next time, guys, good luck on this.